connection. Hello mortals. So today in this video I'll be going ahead and demonstrating my implementation of a Netcat-like tool built inside Python. I'll also go ahead and explain how it works, show how it enables communication between two systems as well. So I'll be doing my demonstration inside Windows Subsystem for Linux. So yeah, let's get started. As we dive deep into this whole project, it will be important for us to first understand what Netcat is and how it works. So to begin with, Netcat is a low-level networking tool that allows direct communication between two machines over TCP or UDP. And what it essentially does is it acts as a road data pipe, meaning whatever is sent on one side is received on the other side. And so because of this characteristic, it is widely used in cybersecurity for debugging, data transfer, and establishing remote connections. And the name I've given to my Netcat Replica is Dog, as you can see. And then so right before we get into the code review and technicalities, it's important to highlight a few key insights. And so in order to replace Netcat, I focused on replicating its core behavior rather than its entire implementation. Why? Because Netcat does more than one thing and in of itself is quite huge. And so what this means is to build the Netcat replica, I had to create a tool that can establish a socket connection and transmit data between two endpoints. And in replicating this, I created its functionality by implementing the same underlying networking principles using Python sockets, which is a built-in library. As for the architecture of Dog, the tool operates in two modes, which we'll see inside the code as well as on the demonstration. The first is going to be the listener mode or the server, which waits for incoming connections, and the client mode initiates the connection. And then from there on, once the connection has been established, both sides can send and receive data simultaneously. So into the code review, as you can see, there isn't so much. We are importing three different libraries, as mentioned, the socket, argument parser, as well as the threading. So on a high level, the server dash listener binds to a port and listens for connections, while the client down here connects to the binded server, and once the connection is made, both will send and receive data. And the threading part allows for receiving data in the background while still allowing user inputs, which is necessary to replicate Netcat's real-time communication behavior. Alright, so as you can see, the listener right here is right there. Here you pass, well, at that's where the host IP is, and then the port in which we are going to be making the call communication between is right there. And that's for the client. The target will be similar. It will be basically the IP address of this host, and the port will be the same port that has been set by the server / listener. Okay. Now onto the demonstration. We shall start up the server and pass in the listen argument, and then specify what port we want. It is important that we don't utilize ports that we don't really want open, or where it will be dangerous to have them open. And then from here on, I will introduce another terminal, which will be the client that will connect to the listener. However, in this case, we will be using different arguments. And for this use case, we can go ahead and try connecting to a different port than what has been initialized in the listener, just to see what the program is going to throw out. What did I do wrong? I did not put in an argument for the target. I have to put in the IP address for the host. Okay. So you can see, even though I did put in the right IP address, it shows us that we have a failed connection due to port mismatch. It's not throwing out that exact error code, but I know that, which means this would be a good area of improvement to work on the error return codes. Anyway, so let's go ahead and utilize the correct port number, and we'll find out that the connection has been established. Okay, so let me just do this right here. Right there. And then we can test communication. I say hi, and we can say it on the listener. We can see the message that I sent from the client, and I can also go to the listener / server and respond to that same message. And if I come back to the client, I'll find that the message has been received and is printed on the terminal. So as you can see, both endpoints can send and receive data independently, which replicates Netcat's behavior as a raw communication channel. And now, again, here at the end, as I have closed the connection, another good point of improvement is coming here on the listener / server and printing out whenever a connection has been closed, since there has been a printout of when an incoming connection was established. So I think it's always good to watch out for areas of improvement. But yeah, in a nutshell, this project demonstrates how low-level socket programming can be used to recreate foundational networking tools like Netcat, and it does serve as a base for more advanced security tooling. Thank you for tuning in.